thank you everyone for being here. I really appreciate the opportunity to speak to you and for you to come and watch this talk with me. So without further ado, welcome to Observability in Production Applications with OpenTelemetry, presented by your host and narrator, Nathaniel. And our entire presentation today will be Apache 2.0 licensed. So just to quickly introduce myself, my name's Ron. It's pronounced like the river in France. If you're having trouble, just call me Ron. It's okay. On top of that, I work at Cisco. You might know them for their Wi-Fis and routers and switches. I work in a different division where we work on some really, really cool projects such as CNCF projects. Raise your hand if you're familiar with CNCF. Okay, very few hands, but a few. CNCF, it stands for Cloud Native Computing Foundation. It's a subdivision part of the Linux Foundation, trying to advance container technology in the cloud. So today we're going to be talking about a few things. One is, what is observability at its core? From there, we're going to be moving on to what is OpenTelemetry, and we're going to be comparing the two. From there, we're going to be asking, and then also answering, how can we add OpenTelemetry to your applications today? And then where does all of this data go? So by the end of this talk, I want to take anybody here who's a complete beginner in observability, OpenTelemetry, and all of the above, and having them leave as somewhat of an expert and very, very educated about the topic. So let's start with the basics, and we'll start with the fundamentals and go from A to Z. What is observability? Can anybody just shout it out, just take a guess? What does observability mean to you? I'm going to be waiting. Yeah, really good guess. It's that, and even more than that. It's your understanding of the internal states of a system given only its external outputs. So just to give you an example, we can look at a person that's aging over time. Feel free to shout it out. What's happening to this person as he's aging? Some white hair. So he's got some white hair. He's got a different beard. Maybe the shirt fits him a little bit differently. Another example is a star that's burning. So what we're seeing here are only external clues that hint as to the millions and millions of events that are happening inside. We don't really know what's happening on the inside of the star just by looking at the outside. But every year we become a little bit smarter based off events that we witness and so on. So this is really good. And we now understand what observability means. And now, since we're here at Elastic, we might ask ourselves, can we apply this principle to applications? Can we observe them? That raises another question, actually. What is an application? We need to define that as well. So for you, is an application typically, is it a monolith that's hosted on premises with an entire IT team just to manage it and a whole warehouse just to house it? So probably not. Over the last 10 to 15 years, we've seen a huge rise in the trend of going from a monolith that's hosted on premises to, in the middle, a monolith that's hosted in the cloud, and now eventually a microservice architecture in the cloud. So we split up the monolith into smaller components, and each one's responsible for only an atomic unit of work, and they can scale up independently and so on. We can zoom in on an example of a microservice architecture. We can look at a web store. This is a distributed web store. It's got tons of different microservices. Some are working and some are failing, as you can see by the red lines for those in the back. So this microservice architecture, it's definitely got a few benefits. For one, it's more scalable. For two, the blast radius of bugs can be much smaller. And then on top of that, it even can support smaller development teams. So it sounds a lot easier, less startup time. It sounds really good at the surface, right? Well, when you start living this day to day with microservices, you come across a few challenges that they introduce. And there are three main challenges that we're going to be talking about. For one, they're really hard to observe. You have no idea what services we are using in any given moment in time. And also, we have no idea what services we are using in each request flow. On top of that, they're really hard to troubleshoot. So say you have an alert going off and too many 500s are being returned to the end user. Finding the root cause of those 500s, it can be very difficult. You have to jump between the different logs of the different services and hoping that you come across the root cause. And sometimes it doesn't happen immediately, sometimes it does. And on top of that, it's really hard to optimize. So finding the component that's responsible for a performance issue, or sometimes even knowing that you have a performance issue, it can be very hard. It can be right under your nose. We have no idea that it's happening. we need something to help us figure out these challenges, something that's called telemetry data. This word could be new to a few of us, so we're going to go over what is telemetry data. Telemetry, just by itself, just the word telemetry, it means the measure of the current state of a system. So that might help us figure out, okay, we need to measure some things about our application and figure out what's going on. Today, in the observability world, these three pillars of observability constitute our telemetry data. We've got metrics, logs, and traces. And each one is a whole world. So just raise your hands if you've used metrics at work. Okay, almost all of us. And logs, all of us. And traces. Okay, a good portion. But not even half the room. So we're going to be focusing on traces. I think that's the area that's new for most of us and could be the most beneficial. And so just to quickly go over the difference between all of them. Metrics, they're a series of numbers that measure activity, and they really help answer kind of what questions. And we can ask what questions on the business side. We can ask what items are being added to user carts. We can also ask on the application side. We can ask what is the 99th percentile of a duration of a request. Metrics are amazing at answering what questions. And logs, we all know them. They're standard output, standard error. They help answer our why questions. Why did this service fail? If you have an error and you have the relevant log, you can see the answer pretty fast. And traces, this is the area that's going to be new for us. We're going to be zooming in, so it's okay if you're confused at the very beginning. But they help answer our where questions. They help you find out where in a distributed trace did this request flow fail. So these three pillars of observability, metrics, logs, and traces, they help and create a telemetry data stack called MELT. Metrics, logs, and traces. Before I knew what MELT was, I saw this word thrown around all the time. I was super confused and I had no idea what it meant. So in case you hear it, just so you know what it means. Let's take an example of a distributed trace. So this is what a trace looks like. You can think of it as a greater transaction, starting at the root and then finishing on one of the child nodes. Each one represents, each circle that you see here, we call it a span. A span is pretty much one atomic unit of work or compute. So we see here, in a distributed environment, each span is probably being hosted on a different machine. So one could be in a different region, they can be halfway across the world. And the way I like to think of the relationship between traces and spans is that a trace is a family, and then a span is just one person in the family. This is, you can think of it, the great-grandfather span, and this is his son, and he has 3 children, and so on. So we can move forward, but before we move forward, I want you to look at this architecture for a second of this application, and think of an application that you work with or that you built in the past. I want you to imagine your application in terms of these icons. What would it look like? I want you to raise your hand if you have an image in your head of an application that you've experienced and that you're familiar with in terms of these icons and spans. Okay, very few of us. That's good. So we're going to move forward, and together we're going to be trying to implement observability right now. To implement observability in a distributed environment, we're going to need 3 major things. One is an instrumentation framework. And let's also break down what does instrumentation mean, because before I knew what it means, I also heard it a million times, and I had no idea what it meant. When an application is instrumented, it means that it's just generating telemetry data for us. It's as simple as that. It has nothing to do with real instruments and an orchestra. And on top of an instrumentation framework, we're also going to need a place to send the data, the telemetry data, and a way to visualize it. So a way to interact with it, a way to understand what we're looking at. So I'm very grateful to introduce to you today OpenTelemetry. OpenTelemetry comes as a mini fix to some of our problems, but it's very crucial in this part of instrumenting applications. And what is it? It's a collection of tools and APIs and SDKs used to instrument, generate, collect, and export telemetry data. I know it sounds like a lot of words that are very useless, but you'll see each one of these words actually plays a very crucial role in OpenTelemetry. We're going to start with the architecture just to understand, and don't be alarmed if it's a lot for you. We're going to be breaking it down step by step. We're going to be focusing at first on this left-hand side here, on the application. So every application has a platform where the code is running, and between the application that you wrote and your libraries and frameworks that you depend on sits OpenTelemetry. It sits in the middle so that it can hook into all of your applications and frameworks to automatically instrument them for you. The API and SDK we see here in the middle, these are responsible for generating and creating the spans for us. From there, they send to a processor, that's a queue, which can apply a function to all of your spans. And from there, it's sent to an exporter, which is also a queue, but it's responsible for sending your telemetry data out through the internet. From there, it could be sent on, as we see in the middle, an OpenTelemetry collector. And as you see with the star, it can be sent to any number of telemetry collectors in the middle across the way. So collector A, B, C, D. And then finally, your telemetry data should be stored in a telemetry backend of some sort. We'll break down in the collector and the backend very soon. But on the application side, there are two main ways to generate traces for us. So imagine you have an application written in Python, and you want it to generate traces for us. So we can either use the core repo. This just includes the API and SDK, and we can manually create their own spans. Or we can use the contrib repo. The contrib repo is full of automatic third-party instrumentations. Say use Flask or use any sort of popular framework or library. You can use the contrib repo and it can automatically hook in and generate spans for us on the fly. Now, why do we do this? I want to take you back to this example we saw a second ago. And I want you to imagine that you wrote this application, and it's just in Python, for example. And then you are responsible for each compute unit, you had to create a span, add the timestamp, add the name, add metadata, add maybe content if you like, somehow put it into the right trace, somehow put it in the right order within the right trace. And it's a lot of work. OpenTelemetry can do all of that for us. So that's the power of the contrib repo. And that's probably the one we're going to be focusing on the most in the rest of this presentation, because that's probably what you'll be using at your workplace. Moving on to the collector. So a collector is very similar to what we saw earlier. It's made up of a receiver, a processor, and an exporter. Now, the only difference from what we saw earlier is that instead of generating spans, it just has a receiver. It listens and it waits for spans to come in. It can process them, and then it exports them again, and so on. Kind of like a middleman for your telemetry data. And then a star, as we see, and then a telemetry backend. Well, you might be asking yourself, why are we reusing these components? Why do we have an exporter and a processor again? Couldn't we just send the data straight from the application to the telemetry backend? Now, I want someone to take a guess here. Do we need a collector? Yes or no? I heard yes. Anyone else? What was that?
Agent is able to connect directly to the data set, then we don't want collector. Collector is just it's like a broker.
It's like a broker, exactly. Mm-hmm. Right. Now that's the correct answer. Great answer. So that's true. It entirely depends on the application. Some backends require you to have some sort of authentication that only the collector can apply, for example. But if there is no strict requirements, we could send directly from the application to the backend. However, there are a few reasons why we want a collector there and to have this broker in the middle. And the reason for that is to one, it can reduce load from the application. And on top of that, it can also separate between business logic and monitoring logic, which comes as a huge benefit for us. And I want to also ask you another question. Why are we using the term OpenTelemetry backend over there on the right-hand side? Why are we using the word backend so vaguely and generically? I mean, backend to me can mean anything. So if we're using the term backend, does that mean that OpenTelemetry is just a client? So yes, we need to understand that OpenTelemetry is just a client for instrumentation. It's not the backend. It's not the visualizer. So then you ask yourself, where can we send all of our data? I'm left with all this telemetry data I've created. I don't know what to do with it. Well, luckily for us, given where we are. So we have amazing Elastic APM. APM stands for Application Performance Monitoring. It's this whole category of monitoring and observability. And they have amazing support for metrics, for logs, and for traces as well. So they're really good. They're very easy to hook up to. And you can just send your telemetry data straight through it, and you'll be able to interact with it. Here, we're just on PowerPoint. We're not going to do a live demo. Sorry. And next, I want you to look at this document. It might be a bit tough for us in the back, but I want someone to just shout it out and guess. What are we looking at here? JSON, but JSON of what? What is this object representing? Right, exactly. So traces was a partial answer, sure, but span is the correct answer. A JSON would be an object with it enclosed out of this. So this is a span, that's right. As we see, a span has a name, it's just the name you give it. It has context, telling it which trace it's in and what span it's in. And remember, the span ID, for every span, it's unique within that trace, but every span within the same trace has the same trace ID. It's like your first name, last name. On top of that, we can see parent ID is null. There's no parent ID. We call that the root span in a trace. And then we see the name is root. So it kind of makes sense to us. We see there's a start time, end time, status code. And then it also comes with information and telemetry about the specific SDK that it's using for generating traces. This really helps in debugging and finding out what's going on. So I want you to take for a popular framework, we can think of Flask and Python. And I want you to ask yourself, okay, so how can we use the contrib repo and instrument Flask ourselves? And here's a hint from when I'm not here. You could just Google it, OpenTelemetry Flask, instrumentation Python. You'll get the answer and it'll tell you, all you need to do is just import and then instantiate this one class. It's very easy. You're like, okay, I can do that. Copy, paste, I'm done. So it's very fast, it's very automatic. And then a lot of people ask, what does it mean automatic? What is it like? Is it I wish it like boom, it's done, or is it a few days of work and it's done? What does it mean? So we found that with OpenTelemetry, we can instrument your application, generate traces and spans and logs and metrics, all in less than 5 lines of code. So less than 5 lines of code that you can insert the application, we've instrumented it. It sounds amazing, right? So we went to a lot of teams. You won't believe how many teams told us it's way too difficult. They said, no, can't do that. That will never happen. And every team has a different reason why. Some teams say, we have too many applications. It's in the thousands. It'll take us years to do that. Some teams say, I'm interested in doing that, but I might need to remove it later on in the future. So I don't have time to do both. And some teams just give a more generic, vague answer, say, we don't have the time or energy or resources, and it ends up not happening. So the contributors of OpenTelemetry, they listened, they heard this feedback, they took it internally, and then they thought of a solution to overcome these challenges. And they came up with no-code automatic instrumentation. Now, what does that mean? No code meaning no changes to your source code. We take your source code as is. Automatic meaning really automatic. And instrumentation meaning generate telemetry and spans and traces. You can do it very, very easily through the command line, environment variables, Kubernetes, for serverless functions such as AWS Lambda, and there are more and more coming out every day. If there's something that you use that's not supported by OpenTelemetry, you can actually be the contributor who adds it. So it's really easy to get into. There's a huge community. There's tons of free documentation on the internet. All the code is free and open source on GitHub. You can log in right now. You don't even need a login. You can just go to GitHub without even a user, see all the code there is. You can join a Slack, SIG meetings, and it's very, very easy and very welcoming to be part of the community. So I really hope you guys will join. I hope for someone who didn't know anything about OpenTelemetry, we'll just jump straight in and add instrumentation for something. Again, here's the license I mentioned earlier. I wasn't joking. And thank you very much for being here today. I really appreciate your time, and I'll take any questions you may have. Thank you.
Thank you. One of my favorite things about Elastic right now is that our native support for OpenTelemetry makes it really easy to work with. But let's start with you for questions.
When you use OpenTelemetry, what are the performance implications for the applications that use that?
Could you repeat it?
Performance implications when you use your OpenTelemetry, like do you need a lot of RAM?
Okay.
You know, those kind of things. Like, does it bog down my applications when I use it?
Okay. So the question, correct me if I'm wrong, is does OpenTelemetry, does it take a lot of overhead in your applications?
Yeah.
Is it huge? Is it space? So the answer is that OpenTelemetry from the very start has been trying to be as small as it can be possibly. If you look up online, the agent, it's only a couple lines. It's really, really as small as possible. And there should be no really implication in terms of memory, in terms of RAM, in terms of speed, in terms of latency. The whole point is that it doesn't affect your application.
Thank you.
No, the OpenTelemetry agent, okay, it's sitting inside the application and generate the logs and sending to collector called APM, right?
Right.
But how will you deal with this? What is that application without touching the application? How will you do that one? Because when you are configuring with the IaaS server or any other server, we have to do the Java agent inside the server, right? So it's going to hit the performance of application by default, right?
By default, yeah, sure. It will take an impact on the performance of the application. The whole point is to minimize it as much as we can.
So is there any way to move the agent out of application and monitor through some URL or any path, providing path?
I didn't catch that.
No?
What was the second part?
No. Can we keep the agent outside of application?
Yeah.
Okay, and running somewhere in the server, and we can collect the data to send to APM?
Oh, yeah, yeah. For example, in Kubernetes, the agent could be in a sidecar, for example, if that's what you're asking.
Yeah.
Mhm.
Outside of application.
Yeah, for a normal application, for example, you just run it on your own computer. It will sit inside your applications, but there are special circumstances like Kubernetes where it can sit outside, or for AWS Lambda, it can sit outside.
Thanks.
Did that answer your question?
Yeah, okay.
Sure. Thank you.
How do you compare OpenTelemetry with
So AppDynamics, they actually, so everything started back in Open Tracing and Open Census. These are older frameworks. And then since then, AppDynamics has actually been upgraded to support OpenTelemetry. The whole community understands that OpenTelemetry, it's a golden unified standard rather than every vendor having their own tracing agent. So OpenTelemetry is just the telemetry client to generate traces. AppDynamics, you can think of it as the server and the backend and the visualizer. It doesn't compete against OpenTelemetry. It supports it.
Hi.
Thank you for asking.
Yeah. Hi. Sorry, quick question. On self-hosted applications of OpenTelemetry, so basically if I host my own instance of OpenTelemetry on a Docker container, Kubernetes, does the data that I send to OpenTelemetry go anywhere outside of that self-host for processing, or is it all done in-house, if you will?
So you'll need to specify. So let's go back to this, the architecture, so we can be on the same page. So are you talking about self-hosting a collector, for example? Or your
Yeah,
application?
self-hosting a OpenTelemetry instance, yeah.
Sure. So say you self-host your own application, you self-host your own collector as well. From there, you could take an open source backend, self-host that as well, but you would have to manually send it there. It's not being sent to some spyware somewhere, across the globe. You have to specify the endpoint you want to send it to, and it sends it there.
Okay,
So
okay.
you can either use a commercial vendor and send it there, or your own self-hosted instance and send it there.
Okay, perfect. Thank you.
Thank you for asking.
Hi, thanks. I understand that the Elastic Common Schema was donated to the OpenTelemetry schema.
Mhm.
What's the state of the schema generally? Like, are these field names pretty standardized? Can people customize them? Is it still all over the place, or how standard is the schema?
The schema is pretty standard, as it's evolving every day as we speak. There is a standard within the community that's pretty stable. But on top of that, because it's open source and you'd like to change it up for your own internal usage, you could fork it, change the names however you'd like, do whatever. But there is a stable convention within OpenTelemetry.
Oh, good, for all the fields. That's great.
Mhm.
Thanks.
Thank you.
What would be your advice if I'm coming from a traditional monitoring observability to open telemetry migrations? That's what we are starting on, but do you have any thoughts, or like how do we go from there?
Can I ask a question? What are you using? What's the traditional?
Dynatrace or a non-open telemetry way, but all those inbuilt systems and stuff. So, but we really want to move to open telemetry with all our cloud, because kind of build up a lot of clouds, multi-cloud or hybrid kind of. So how do I take those to that level, and how do I start, and how do I vision that?
Yeah, my one piece of advice would be, because we've seen in the past, before there was OpenTelemetry, and there was different commercial vendors of open tracing, let's say Dynatrace and X, Y, and Z. And when customers wanted to test trial and they wanted to see Dynatrace versus company A, they would add both instrumentations to their applications, and they experienced extremely unwanted side effects from it. And so my suggestion would be not to double instrument your application, but to do it one at a time. Remove the Dynatrace or the proprietary instrumentation, and then to add OpenTelemetry and send it to your own self-hosted, for example, either be Elastic or an open source backend, and see it one at a time. And I would say just don't double instrument an application.
Cool. We have time for one more question. All right.
This is pretty cool. I didn't know about this.
Thank you.
So I'm looking at the packages that are available, and it doesn't seem like there's one for Elasticsearch specifically. Can you speak to that?
Sure.
We do have a new Elastic version of it's called EDOT, which is the Elastic distribution of OpenTelemetry, and it's a new SDK. It's currently in beta, and I've played with it a little bit, so come find me after to see how I've done it. I actually have like a demo and stuff, but I'll turn it over to the actual speaker.
So yeah, Elastic, it's so well versed. They created their own distribution of OpenTelemetry. So you can use that, or you can use normal OpenTelemetry, and you could just send Elastic as the endpoint you'd like to send your traces to. But Jessica, I have one question. There was one gentleman in the back who had a question.
Oh yeah, sorry, I don't always see everybody, so I appreciate that.
As far as I understand, you're talking especially about traces with spans or metrics or logs generated from the application itself. What about system logs or system metrics or database metrics or database logs, for example?
Now that's a great question, because you have your own application, you add OpenTelemetry instrumentation to it. And then the question is, well, you have, for example, the collector, which is your own self-hosted application, and you'd like to see metrics on that, and how's that doing? And also also the database that you may be hosting it on. And so OpenTelemetry supports that. You can add your own field within the collector and within the database that you can send that as well as metrics and as logs to the OpenTelemetry collection circle. So that is supported as well. But that's a great question.
Thank you.
Thank you for asking. And again, I want to thank everyone for their time. I really appreciate being here and talking to you today.